Inverse. An inverse semi. What is an inverse? Like the opposite. It's the opposite. Okay. So an opposite. Anyone else is an inverse? Have you done questions on answering inverse last year? No. First time. Put your hand up. First time you heard the word inverse, or the first time you are going to do inverses today? Okay. Don't don't know. Okay. So an inverse simply, as Zach said, is sort of an opposite. Now we have an fx equals 2ex plus 3, but we are not going to graph this. We're going to graph the inverse. We've got our notation f colon r to r. That's all pretty usual. You should be familiar with that. State the domain. What comes to mind with domain? The x's, and the range, the y's. Now, an inverse is simply mathematically, let's do this as an inverse. If I have, let's say this is 3 and this is 2, 3, 2. And what would the inverse of 3 and 2? Does anyone know what would that be? An inverse of 3, 2. Good try, though it's incorrect. Good try. It's a 2 and 3. We're going to reverse, do the opposite. What does that look like? That means 2's here and 3's out here. Okay? When you swap a 3 and a 2 and a 2 and a 3, guess what? You can see if you tilt your head to the right, it's all symmetrical. Along what equation? What's that dotted line? A y equals x. Thanks, Tim. So an inverse is simply, graphically, we mirror across our y equals x. Mathematically, a y becomes an x or x becomes a y. So in our equation, our y's become x's. So we are now going to do this. This is now the inverse that we're working towards. This is what we want to sketch. But we don't sketch equations that are x equals 2. We're always sketching things that are y equals 2. What must I do to this graph, Manny, in order to get to there? Okay.
Turn it right.
We are going to turn the graphically in a second, but I want it mathematically. Okay, so this is f of x. This here is an inverse of our f of x, our opposite. So, but I want to get to y. What do I need to detach from this side here so that I start getting y by itself? Maya, what's the first thing that you would do? It's e to the power of y plus 3. I've got it times by 2. How do I backtrack that? Divided by 2. Next question. What's the next step? I've got an e, or exponential, base e. I've got y plus 3 up in the branches. I want to bring it down. If I've got a base e here and I want to bring it over to the other side, what does it become, Zach?
Doesn't it become like y plus 30 equals log a x 2?
Good. A base e on the other side is the same as the base e underneath the log on the other side. Last step, Jesse. I'm going to get y equals to
Minus 3.
minus 3. Okay, so we're graphing that now. Let's erase this. Eventually have to sketch. Okay. What do we normally look for when we're graphing Perry? What normal features? Intercepts. Okay. How would you do the first intercept? What would you sub? Y equals 0? So we are finding, say, if y equals 0, what are we trying to find? Which intercept? Say, the x or the y intercept?
Yeah.
The x intercept. So down here, I'm going to just write this in our usual form. Okay. So x-intercept y equals 0. Can anyone help me? I want to find my x now. Emily? Move the 3 over. I'm still trying to get to x. Tim? What must I do here?
Find a log.
Find the log. So what should I write? I want to get rid of this log and the base to get to the x on 2. What do I need to do?
Log is 3 plus x over 2.
Close. I can't move the log over there, but I can move the base.
Oh,
E, good. Just E. Okay. Last step. Jesse, what's x equal to? Yeah, times 1, 2e3. Okay. 2e3, if you put that in your calculator, is 40.17. Double check that for me if you'd like. So we've got that. X equals 0, y-intercept. Just as we simply do our lines, we're finding intercepts. I've got that. What's my answer? Good try. Good try.
3.
Good try. Zero divided by 2 is a 0. What are we getting at here? It's undefined. Okay, you cannot get a log of a 0 at all. You can get a log 1. What log are you on? That's 0. But that's not that. This is log 0. So we're now going to graph this out. Okay. Is everyone okay? Any questions? Now, in your exponentials or logs, there's always asymptotes hanging around. It's a 3-step process for logs and exponentials: x-intercept, y-intercept, and your asymptote. So if my equation is this, so try to draw out my asymptote. I do not want that to equal 0. So we're just going to focus as if we're looking at it. That can't equal 0. If I say If I detach r divided by 2, so 2 times 0 equals 0. What does that mean? Undefined at x equals 0. So we found our asymptote. Do not get this mixed up. Our asymptote here, x equals 0, is this guy right here. It's not flat, it's the one going up and down. Okay. Let's start plotting our 40.17. Might be a good idea. 1, 2, 3. That's 40. Adjust the scale as need be. Okay, and because our y values aren't that big, we can go up and down like so, as normal. Okay, so 40.17, x-intercept there. There is no y-intercept. It's like a invisible wall that you can't get through. Like lines, we need, it's a good idea to get two dots. We've got one so far. So if I have this equation here, once again, and what sort of number can I put into x so that I get a nice whole number as my final answer? What can I get x to be so I've got a nice 2? Excellent. So this sort of technique helps us to look for points where things sort of disappear quite naturally. A log E1 Perry, what's that? It's a 0. Okay, so now I'm plotting 2, -3. You can plot whatever you want, but you might end up with the decimal, which you don't want to do. This is a good technique if you've only got your pen and your brain in hand. I'll look for a 2, -3. 2, -3, 1, 2, 3 is about here. Okay. Logs, like exponentials, are curving, and it's got to be as best as you can. Something like that. My domain and my range is the last thing we have to do. So my x values for my domain all the way to infinity, but it stops at this invisible wall. How would I describe that? So
Would you call it just
if I wanted it in a bracket,
0 to infinity?
0 to infinity. Do I want curves or square brackets? Can I?
Sure.
Not sure. Who wants to finish that off? I want curves. Curves do not touch. We will never touch the ceiling.
Okay.
You will never touch infinity. Infinity is always one step ahead of you. Range, Jesse, range, up and down. Good. Infinite. Can you use the R, or all the way up and down, or infinitely negative, or infinitely positive. Any questions? Okay, let's do one more. And then you'll have the rest of the double to do the work. But I'll also show you something on a calculator. Okay. So that was that question. Okay, extra example. Excuse me, it's pretty fiddly on this. Find the inverse of the function f, 2 to infinity. Now we've got a log. Just by looking at the log, and we're doing an inverse. Can anyone tell me what sort of graph we're going to end up with? If it's a log base 10, an exponential, with what base? I heard it. Base 10. It's going to be base 10. So, step 1. Sub x for y. Inverse. Say, what's the first thing that I undo if I want to get to y? Is it the 2, the 10, the 3, or the 1?
Take away the 1.
Take away the 1. What's my next thing, Zach?
You put the 3 in the y minus 2.
With the 3?
Or do you just like,
Yeah. Which one is it, Zach? Have a go.
divide by 3?
Excellent. Okay. Make sure you divide by both things that are already there. Okay. Jesse, what do I do next?
Move the 10 over group 10 to the power. Yeah.
Excellent. Okay. Last step, we just simply add the 2. So y equals 10, x minus 1 on 3, and plus 2. Okay. Now, just by looking at this, asymptotes are tricky. But with your exponentials, remember, the thing at the end, the constant at the end is the asymptote, y. Okay, let's think of it this way. Under sentence here. As x gets smaller, if that gets smaller, y is approaching what? Okay, let's just say if it was 100. 100 take away 1 is a 99. 99 divided by 3 is about 33. 10 to the power 33, really, really, really big. If I now bring it down to, let's go down to 0. If that was a 0. 0 take away 1 divided by 3. 10 to the power of a negative third. As x becomes smaller, what's happening to this? As x goes down, what's happening to this? Or you're close. What is this approaching? What value? The bigger x becomes, what does this part of the equation, what value is it approaching? Not quite. Not quite. Okay. Let's do a negative 99. Let's go to the negatives, as if x was a negative 99. Negative 99 take away 1 is negative 100 on 3. But it's 10 to the power of a really, really big negative number.
Close to 0.
It's good man. Okay. It's going close to 0. 10 to the power of 100 is really big. 10 to the power of negative 100, that's really 1 on 10 to the power of 100. That's a really, 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 really small fraction. It's still a fraction, it's still there, but as Manny said, it's approaching 0. So this will eventually disappear As x gets smaller, you're going to be left with the asymptote of a 2. Y is approaching to 2. Okay, this is a bit tricky to kind of work around in your head. So what does that mean on our graph? If that didn't make sense, that's okay. The rule is any number that's attached at the end of the power is the asymptote. Okay, now let's get some intercepts finally. Almost done. Okay, let's work with this one here. Manny, what do I do first?
No, one.
Minus the 1. Maya, what do I do next? Sorry, Maya. Divide by 3. Emily, what do I do? Remove the log. What is it on the other side? 10 to the negative 1 and 3. Okay. 10 to the negative 1 and 3. I think we're good. Let's see. Are we good? I hope we are. Yeah, we're good. Last step. Tim? Last step. Okay. 10 to the power negative 3 plus 2 is 2.46. Okay. Let's do this one then. Y-intercept x equals 0. Hang on. What did we do wrong? This is also a common mistake. Yes. Thank you, Barry. We actually found out the wrong equation, but you actually get the same answer anyway. We started with the normal equation. We've got to get into the inverse. Let's restart that. But you'll get the same answer in a way. Please make sure. I think a good way to avoid my mistake is explicitly write down that you're working with the inverse. Okay, now let's go again. Okay. Okay, let's go again. Tim, what do I do first? Those two. Zach? Good. What do I do next, Jesse? You do not. Okay. Okay. Jesse, can we have logs of negatives? No. Good. Good answer. You stop. You can work it out if you want. The moment you hit a log negative, you stop. Save yourself the time because it's undefined. Over here, let's go again. I've subbed in my x. Okay. Perry, 10 to the power of what? E 1 on 3 plus 2 is 1 on 10. Third plus 2. This is when you get your calculator. You should get 2.46. Okay. So y is 2.46? This is 2, and 2.46 is about there. Question. I only have 1 point here because of this undefined kind of stopped us in the tracks. The question is, what's a nice little number for x to generate myself another point that's sort of really easy to sort of calculate? What could x be, Manny? 4. Good choice. As Manny puts his 4 inside there, he knows he's after a denominator and numerator of 3. Okay, which gives us, I'm going really quick, 12. So now a 4 and a 12 come together. And I can put here, let's just make sure we're in the right track. 4 is here. My scale's not really very accurate, but it's still a sketch. And we're just going to curve our way from here. And as mathematically that we had before, it's approaching 2. The maths and the graphs are all working together. The maths does not lie. Now, can everyone get your CAS out, please?